This is the chapter 12.1 worksheet video. This video will help you get started on this worksheet and complete it. So let's get started. In problems 1 through 10, use the table feature of a graphing utility to find the indicated limit. What I'm going to do is I'm going to do a couple of these, and then I will, what I would do for you, if I was you, is I would press pause and do the rest of them, and then we'll go forward from there. So I'm going to type in 4x cubed into y1 on my graphing calculator. And now I want to set up my table, and it says use a table feature. So to do that, I'm going to hit my second table set. And what you want to do is you want to set your table up to start it at that 2 value, start it at whatever that number is. So in each case, you might go in and you'll change this. So I'll start it at 2, and I'm going to change my table by a really small increment. I want to know what happens close to 2, not exactly at 2. So after I do that, I'll start it at 2, I'll end it at 2, I'll go to my table function key, and it will tell me values. And at 2 it gives me 32, which is great, but I don't really care about that 232 value. I care what happens here at 1.99 and here at 2.001, and I notice at 1.99 it's getting close to 32. At 2.001 it's getting close to 32. My answer is 32. Let's do another one. Let's do one of these harder ones. Let's try number 10. So first of all, number 10, it says calculator in radians. So I'm going to make sure my mode is in radians, which I had to switch. And I'm going to go tangent x over x, y equals tangent of x. I'm going to use alpha F1 to get my fraction bar. Tangent of x all over x. And on this one, I'm going to go to my table start key, my table set key. I want to start my table at 0 this time. So I'll plug a 0 in, and I'm still going to change it by a really small increment. And I'm going to go to my table, and at 0.001, it's getting closer to 1. Negative at 0.001 positive, it's getting closer to 1. I know at 0 it's an error. I don't really care what happens at 0. I care what happens on each side of 0. So my answer here is 1. So on this section, what you're going to do is you're going to look at your table and you're going to decide, okay, on each side of that value right there, what is the graph getting closer to? What are the numbers, the table values getting closer and closer to? That's how you use a table. I would hit pause and I would do 1 through 10, the ones we haven't done yet. In 11 through 16, use the graph to show graph shown to determine if the limit exists. If it does, find its value. So they're giving us the limit of this function, and this function is this picture of this graph right here. The limit of this function as x goes to 2. So they're saying as I get closer and closer to 2 from each side, as these two graphs get closer and closer to 2, what value are they approaching? And it doesn't matter if it's a solid dot or an open dot. They're saying on each side of 2, what is happening? And I notice on this side of 2, it's climbing up towards 3. And on this side of 2, it's climbing up towards 3. So if I go to 2 and those two graphs are coming together and I go over to 3, my answer is 3. Okay, let's find the limit as x goes to 4. So I'm going to approach 4 from the left. I'm going to approach 4 from the right. There's an open circle, which means there's a hole there, which means at 4 there's no value. But from the left and the right, this value right here, it's dropping down towards 3. This is dropping down towards 3, and I get a value of negative 3. This one. At 2, the answer looks like it's about 2. But as I approach 2 from the left and I approach 2 from the right, as I get closer and closer to 2 on both sides, the value is approaching 4 on both sides. So even though at 2 the answer is about 2, really close to 2 on each side of 2, the answer is 4. again, the limit as the function goes to 2. At 2, the answer is, well, about 1. But as I get closer to 2, and as you get closer to 2, my answer is 2. Number 15. I'm going to approach 3 from the left. I'm going to approach 3 from the right. So I'm going to close in on 3, but I'm on the graphs and I'm closing in on 3, and they don't come together like they're supposed. They're supposed to come together, and whenever we get something like this or like this or something, here's one of those cases where they don't come together, they diverge. So if they diverge, the answer does not exist. And here we are again. I'm getting closer to 4 from the left. I'm getting closer to 4 from the right, but those two are they're not coming together like they should, so they're getting closer. So my answer is the limit does not exist. And I think it's important to note here that this section was a limit at a specific spot. And I could find the limit anywhere on the graph. Like I could find the limit at 8. If I went 8 and I went up to the graph here, it's about right there. And I asked myself, as I converge around 8, as my numbers close in around 8, what is exactly happening? And I'm getting closer and closer there. And I go over to the graph and I notice I get about 7. So I could find the limit as x goes to 8 of f of x, in this case would be approximately 7. Okay, you can hit pause now. I guess we don't need to hit pause. We'll go on to the next section. And we'll go from there. So the last section here, it says graph each function and then use the graph to find the indicated limit if it exists. We're going to do exactly what we did up here, except we are going to do it on our graphing calculator. So, and they don't have little dots for us. So let's do I don't know. Let's do this one. Let's start with 21. I like this one. So I'm going to type in f of x equals 2x, the absolute value of 2x. So, oops, I'm right down here, the absolute value of 2x. So I'm going to go to y equals, I'll clear off what I got. I'll go to my math folder, absolute value of 2x. And I'm going to hit my graph button. And this one, it wants me to look at a limit from a graph. And this wants me to find the limit as x approaches -3. So here's -3. I'm going to approach -3 from the left and -3 from the right. And the nice thing here is I can actually use my cursor button to go over to -3, and it will approximate it right there. And I can go up to the graph, and I can find the value at -3. I can approximate that value on each side of -3. And I notice at -3, the value here is about 6. So I go over to -3, I go up to the graph, and I ask myself, hey, do these numbers, do they converge together? And when they do that, then you go over to the x-axis, or I can look at this, over to the y-axis, or I can look at this value, and at -3, well, my value's about, on my graph there, my value's about 6. So the limit as x goes to -3 of f of x is about 6. Let's try this ln one. This is a different one. So I'm going to try f of x equals ln of x. So I'll go to y equals, and I'll type in the ln of x. The ln of x, and that's a log graph. I'll hit my graph button. And if you remember, this graph actually does go down here along this axis. It doesn't have enough pixels to show it, but I want the limit as x goes to 1. So I look at 1 here, and I ask myself, does this graph and this graph, do they get closer and closer to something as I approach from each side? And the answer is yes. they get closer and closer to 0. So my answer is 0. Now, for your last section, we're actually going to use Desmos. So I went ahead and I downloaded Desmos on my phone. I think this is a good way of doing it. Go find Desmos. There it is. So I got Desmos on my phone, and you can actually type in piecewise graphs on Desmos, and then you can ask the question, what's happening, what's going on at the limit point. So once the limit as x goes to 0 of f of x, and f of x equals x squared when x is greater than 0, greater than or equal to 0, and 2x when x is less than 0. So I can actually type that in. I can type in y equals x squared, and for this there's a funky little bracketized key right here. And what that will do is it will limit the size of the graph that you want to limit the piece. So I'm going to go there, I'm going to hit that little bracket key, and now I'm going to type in x is greater than or equal to 0. And then I'll go hit the rest of that bracket key, or maybe it'll just, well, just shove it in. Oh, it just did it for me when I pop down. So I'm going to type it, that's the first half. So it's basically saying, hey, for x squared graph, you want all x is greater, here's my x is greater than 0, so it wants that half of the graph. So now I'm going to go down here, I'm going to type in y equals 2x, and I want that funky key right there again, and those are for all x is less than 0. X is less than 0, and I'll hit return. And I ask myself on that picture right there, on the picture, I want to find the limit as x goes to 0. So as I get closer and closer to 0, are these two branches coming together? And they are, and they're coming together at 0. So this answer right here is 0. Okay. Let's try to find one here. Let's see if we can find one that maybe doesn't have a limit. I'm not sure here. I'm going to try, this is kind of a funky one. I'm going to try number 34 on my graphing calculator. All right, so let's go back up here. This one just wants, it wants f of x equals 1. So I'll just type in a 1. F of x equals 1, and that's for all x's less than or equal to 0, or less than 0. X is less than 0. So f of x equals 1 when x is less than 0, and then y equals, or f of x equals negative 1 for all x is greater than 0. So there's my picture. F of x or y equals 1 when x is less than 0, and f of x or y equals negative 1 when x is greater than 0. And I look at my picture, and I want to find the limit as x goes to 0. So here I am, approaching the two sides, and I'm looking at it, and they are not coming together. They're supposed to come like this, and they do not, so they're diverging from each other. So this is a limit that does not exist. Okay, so your assignment is to complete this worksheet. It's technology-based. Do your best, and then submit it online. All right, good luck.